Yeah, I'm Gabe here. I've been with Gresham Smith about 5 years doing commissioning. I'm mostly electrical commissioning, and before that, I came from an electrical background and a heavy facilities team background before coming into this.
Okay, so we're going to tell you what we're going to tell you, and we're going to tell you what we're not going to tell you unless you have questions about it afterwards. So we're not going to be very technical in nature, but we can get into that. If you've got questions about what we've done on the facility we're going to be talking about. We're not really going to talk about methodology a lot, but we are going to demonstrate to you the monetary savings that we have in the building we want to be talking about. Just give you some examples and high points. And there should be something here for everyone. And it's really, not about technically what we've done, but the structure of what it takes to have success in an ongoing commissioning effort. I'm not going to spend a lot of time reading from slides today, but I did want to kind of define what ongoing commissioning is. I think this is a wiki definition, but we're basically looking at building performance on an ongoing basis through investigation, analysis, monitoring, operating conditions of building systems. So, and we're talking about, for the particular facility today, a 15+ year effort of just ongoing commissioning results. Okay, why do we do ongoing commissioning? I've summarized it in 3 ways. The benefit to occupants, environmental impact, but the one we really want to focus on, because I think it's what really sells to owners and gets people convinced that they need to be doing it, is the monetary savings. That's what we intend to demonstrate today. Before you get started on your ongoing commissioning effort, you kind of need to know, well, where am I with my building right now? There are benchmarking tools. I like Energy Star, and if you don't know much about it, we can certainly educate you. We're not going to be talking about Energy Star much today, though. We're also not going to be talking about LEED. Not a terrible system, and I love that it's a fundamental requirement that a building is commissioning, or that a building is commissioned. But what we really want to talk about is utility tracking. And the next several slides I'd like for you to pay a lot of attention to, especially if you really like graphs. Before I show you the graphs, let's talk about our example facility. It's located in Nashville, Tennessee. I've lived there, if you can't tell from my accent, for the past 20 years. So this is just down the road from us. It's an 11-story office building, pretty big parking garage, but 324,000 square feet of office. This was built in '99. You really get a lot of mileage out of doing ongoing commissioning on aged facilities, and this one's 25 years old. HVAC systems, this is important. The more complex the HVAC systems are, the more there is to wring out of your utility bills. This has a chilled water system. It's got medium pressure air handling units, if that means anything to you, with air terminal units. Electric reheat is worth mentioning, because the electric reheat can be quite costly if it's not utilized efficiently. What else do we have? Chilled water, condensed water system. Okay, these are our benchmark years, 2006, 2007. This is before we were in the facility. Utility benchmarking is a really simple way to just look at where you've been. So we used 2 years. I want to explain this graph. Across the bottom is January through December, and this is the annual usage. It's actually the monthly usage in kilowatt hours. If you can't see it, that's 800,000 per month on average. So this is before we were in the facility. Let's look at our introductory year, 2008. There was an impact. So the green is the 2008 year, 2006 and 2007 in blue and in gray. I'm going to go through these next graphs very quickly, but I want you to pay attention at the year after year savings. 2009, pretty substantial impact. We're going to keep going, 2010, 2011. All right, you're seeing the graph drop. And this is all because of an ongoing commissioning effort that we undertook with the owner and sometimes contractors. 2015, 16, you'll see around 2017 and 2018, we're averaging around half the utility usage that we were in the benchmark years. This is not due to a decrease in occupancy. It's just us watching, us going into the building and trying to find ways to save energy and make the best usage of the HVAC systems, lighting systems. Gabe's going to talk about the electrical aspect of this. I'm pretty much all mechanical. 2019, I mean, this is a substantial impact. We're going to talk about the monetary impact in just a second. And then you see the asterisk here for 2020. You can see about when COVID hit and the building was deoccupied in April, that dramatic spike or trough. And unfortunately, useful data for utility tracking kind of ended here because the building was deoccupied. We still make substantial efforts in the building to try to save energy, but we can't use, you know, the past 14 or 15 years of occupancy to benchmark anymore. So that's 2021. You see that it's still managing well. Okay, this is annual savings. You see the first year, 2008, a pretty modest impact, $32,000. And by the way, you might estimate that to be your fee for an annual for annual ongoing commissioning for a building like this. You know, $300,000. It might make a lot of sense to have a fee of maybe $30,000 to make either monthly or quarterly site visits and review the building operations. One thing that is misleading about this graph is this says annual savings, not cumulative savings. So even though it rose in every year, what you're looking at, each of those columns represent the annual savings. Okay? Cumulative through 2021, $3.3 million, 3.4. That's a pretty good bang for your buck when you're paying someone $30,000 a year to undertake ongoing commissioning effort. One thing of note is that this does not include demand charges. So this is just, you know, kilowatt hour, you know, figuring, but it's not taking into account the demand charges, which Gabe is going to talk about here in a minute. So when you get into a building and you're going to start doing the ongoing commissioning process, there's several introductory efforts that you have to undertake. You have to verify that everything works the way you think it's working. A lot of times the documentation may not be there, and you just kind of have to tinker with it to figure out how the building operating system is managing. Verifying the ventilation. You want to have your positively pressurized building. If you don't have that, you are going to have moisture issues. You're going to have all kinds of issues. A lot of times you'll go back in and do test and balance effort just to make sure that everything's performing the way you think that it is. The building operations plan. So this is something that you want to hand over to the operating staff so that they understand how the actual facility operates. This is going to be important later when we talk about training and making sure that people understand how their building is operating. Validating system operation, functional performance testing, that's all it is. And then training and trend setup. I'm going to talk a little bit more about training and trend setup. And training is something that you cannot neglect when you're talking about doing ongoing commissioning for any sort of facility. And at this point, I'm going to hand this over to Gabe. He's going to talk a little bit about the electrical aspect.
Morning. So these are some of the things we did in the facility. And when I introduced myself real quick, I said that I came from a electrical background, then a facility background. I worked in this facility for about 10 years, and that's how I got introduced to commissioning, the mechanical side and energy savings and stuff. So a lot of this stuff are things we did while I was there, so I'm pretty familiar with them. Now, there's a lot of numbers here, and there's a lot of information, so any kind of CEU question is all going to come from this power slide right here, so you need to memorize it. No, I'm kidding. We've highlighted the most important stuff here, but what we wanted to point out is we did two big lighting retrofits in the building. one in the garage and one in the interior of the building. So the interior building had all these wall sconces, can lightings that are the 4-pin compact fluorescent 32-watt bulbs. I don't know if y'all, I see some nods, you know what I'm talking about. So that's 32 watts, and what we did was we changed those to 8-watt LEDs, right? Now we've factored in here energy costs for kilowatt hours, how many hours they ran, all kinds of lighting schedules, things like that. We put in here the cost for the bulbs, all that we calculated out, and we come up with a payback of a little over a year and a half, but a savings in highlighted down here, almost 185.8 kilowatt hours per year, just by changing light bulbs out, right? So we took the parking garage. The parking garage, you see we put a total cost, we put labor, this is the one on the right. We had labor here, because what we did in the parking garage was we took 400 fixtures at 175 watts, the big metal halide ones that, they're hot, burn up. We changed the whole fixture to a 48-watt T5 high-efficiency LED lamp. And so once we changed those, that's 400 of them. And you go from 175 watts to 48, 400 times, you're looking at a savings in the garage of almost 300 kilowatt hours annually. So your payback is less than a year and a half on that. Your savings in energy was almost $30,000 just on the garage, and 18.5 on just changing out the bulbs for wall sconces and down can lights. Now they've got, this building's still going through upgrades, it's 99, so they're still changing out bulbs, so there's more energy to be saved as they go through it. But these were two big initial efforts. The parking garage lighting retrofit, which we didn't calculate this in here, but at the time, Nashville Electrical offered a kickback on, there was a payback program designed for changing out the lights to LED. So there was even additional savings that we're not calculating in here, because that's not a guarantee on every single project you go to. So we didn't add it here, but there was also that. So this was very beneficial to the building. On this next graph, we're going to talk a little bit about peak demand and energy. For you guys that pay the bill and stuff in your facilities, everything in yellow is the energy used. That's all day long, that's constant. Something's running, something's operating. And then your demand is in red. So your energy, we've got this, pretty much between 6 a.m. and, the end of the night, 8, 9 o'clock. That's your main use of consumption. That's all your air handlers, cooling towers, lighting, laptops, people coming to work, all that stuff. Your demand is determined by whatever the highest amount of that usage is per day. So what your electrical company wants is once a month, or whatever your pay period is, they want that highest possible demand that you've hit in that month, and then there's a prorated amount that they're going to bill you for. And it is going to be highly substantial to pay that demand charge. I mean, when you're talking cents per energy kilowatts, you're talking $15 to $25 per kilowatt. So what can we do to get that demand down, right? Because you're going to have that highest peak no matter what. Right here, we've got it at noon in the day. This is typical for a facility that, let's say, has, the facility we're talking about has a cafeteria in it. Everybody goes to lunch in the cafeteria. You got all the ovens running. Hottest time of the day, so your air handlers are all running. This facility has a gym in it, right? That gym has a shower. We got water heaters running. So midday, everything is ramped up as high as it can be, sun's in there. So we've got this huge peak at that day. To lower that peak, there's certain things you can do, right? On this graph, we've got a little minor peak right here. And we're asking, what is that spike? Anybody got an idea? Startup. So at 6 a.m., what was happening is this building was on a time of day schedule. And at 6 a.m., everything started, and at 7 o'clock at night, everything turned off, right? Well, this 6 a.m. peak, we were actually creating. So what do you do? Like, we have a normal peak at noon, but what do you do on a day where it's cloudy, gray, nobody's coming to work, it's Friday afternoon, cafeteria's barely running? all of a sudden your highest peak is not that noon peak, but it's this one at 6 a.m. because you have, in our facility here, we've got 2 chillers, 2 cooling towers, pumps. We also have 13 air handlers. So 13 air handlers turn on at 6 a.m. And what we did was, we looked at this as commissioning and went, okay, your facility's main charges are between 6 and 7. That's dictated by your local jurisdiction that sells. NES is our electrical system in Tennessee. We use in Middle Tennessee. So we staggered all the equipment to come on starting at like 4:30. These floors come on, then at 4:45, then at 5 o'clock. And by staggering those out, we've removed that first morning peak, right? So you're always going to have that highest demand of the day. All we can do is lower our energy usage and try to bring that peak down so that you're not paying it at the highest rate it can be possibly hit. So this is an example of 2 electric bills, kind of. On the left, you'll see 2 different companies, and what I'm trying to show here on this one is how much your demand charge affects your bill monetarily. So even though on Company A, and Company A and Company B are generic companies that we're just using as an example, but we want to show that your peak power demand there, it's only 10% because it's a very high energy usage building. But when you have the same exact peak on a low energy usage building, the demand charge still affects it over 50%, right? So that's how much your demand charge is important. Regardless of the energy used, the demand charge is really hitting you. Now, if you look to the right, this is an actual utility bill for the facility we're talking about. If you'll look at it, it's got its, kilowatt hours, everything. Right here, we've highlighted they're paying kilowatt hours, $19.80 for kilowatt. Above it, they're paying 0.06 in your kilowatt hours. So kilowatt hours is your energy used, your kilowatts is your demand charge. So if you look at this bill, the total bill down here is like $46.7 thousand a month. $15.9 thousand is your demand charge. A third of that bill comes from the demand charge. So that energy, we're going to use it. We can try to lower it through lighting retrofits and through other things, but that demand charge, if you can bring that down, that's going to help tremendously. So some of the things you can do to bring down that peak demand. Stagger the timing of the loads. That's what we did in the morning. That's, for everything. Pump startups, stagger those. Stagger the fan startups, chiller startups, Basically, you're just trying to give the building time to get up to speed instead of hitting it all at once. Modulating motor usages, VFDs, ECMs, those are for like small orders, but the VFDs, this is a facility that did a complete retrofit, a 20-year upgrade on the chillers. It had solid state electrical components in it. When it came on, it pulled in the electrical contactor and just slammed it on, 0 to 100. The outside air fan of the building, 0 to 100 when it ran. Just by putting VFDs on the chillers and ramping it up, putting VFDs on the outside air fan, it allowed us to modulate, so now we're not using 100% all the time when we needed it. And we were, just the startup alone of the equipment, putting the drives on, we were able to provide a payback that showed just starting it up saved energy. And then the last thing down there, we got reducing that overall power, right? So to bring the demand down, we just need to bring the overall energy down so the peak is not as high. And we've done that through lighting retrofits and, other minor things. The lighting retrofit was probably the biggest impact because there's still room to grow on it. So that's some of the things we did on the peak demand. Joe's going to do a little talking on trending and more of the mechanical side of things. And I'll turn it back over to him.
Peak demand where we are, it gets set once a year, or once every 11 months at the highest, so it's not on a monthly basis for the year.
Okay.
So we set the peak at usually July.
Yeah. Yeah, it's usually summer, July.
So what you're trying to do is try to shave that peak, because what I get in January or anything else, they're just going to use July's and get that bill up.
Correct. But you're getting billed monthly
Yeah.
for it, right? So every month you're hitting a peak. But yeah, you're correct. They're trying to.
For 11
Yeah.
months.
Yeah, they don't want you to pay a peak demand in January because it's going to be way higher in July.
Yeah.
So
So this $3.4 million What Gabe was referring to is the peak demand charges. This could easily be $5 million worth of savings if we cared to calculate it. I didn't think it was really necessary. I think the number itself, the number speaks for itself. So, yeah, $5 million over the course of 10 to 12 years. And by the way, we're talking about annual fees for a building of $300,000 being something like $30,000 on a commissioning effort. The introductory effort might be a little bit more expensive because you have to do your homework. But I did want to rewind to this just after Gabe was talking about the demand charges, just to let you know that this number is lower than the actual savings. So we've talked a lot about like things that we wanted, things that you can do in a building. I want to touch on trends because most building operation systems, most building automation systems have some sort of trend reports that they can spit out. You don't actually have to be at the building in order to review trends and gather good data from what the trends have to tell you. There are some pros and cons to these. I mean, they're pretty much free for any building automation system. Your JCI and your Siemens, Train, they're all going to have trends available to be provided in like a CSV format or Excel format. And you can write some code or you can review the tabular data to get some good information there, and you don't have to be on site to give some pretty good perspective about what's going on with the facility. So it's also great for analyzing any sort of anomalies. Maybe there's something weird going on in the building that you're not there to catch at midnight or 2 o'clock in the morning, that kind of thing. If you've got trends, you can kind of figure out exactly what's going on. You can use them to identify energy conservation measures. That is a very useful tool or a very useful implementation of trends. You kind of got to know what you're doing, but ECMs, occupant comfort validation. No one's ever happy, or maybe some people are happy, but everyone's not happy. Like you can't please all the people all the time, and you can use the trends for air terminal units, thermostats, and things like that to validate whether or not someone is actually whether or not the systems are performing, or someone is just uncomfortable because they're always going to be uncomfortable. There are some cons to trends. You have to set them up correctly, and if they're not set up correctly, it can be a real headache. Depending on the system, you might have to download these, every week because the data is overwritten, that kind of thing. You can have trends reporting for a year, and if no one ever looks at them, it doesn't mean anything. So you can spend a lot of time setting up trends. You actually have to do the legwork to review them and analyze the actual data. And they're only as good as they are reliable, which means if you've got bad sensors, you're getting bad intelligence, and it's going to lead you to wrong conclusions. So, if you're setting up trends for a facility, there's certain things you want to make sure that you're doing. And one of those is validating that the information that you're getting is actually correct. Okay, so we've talked a lot about things you can do in a building to reduce energy usage, but it's not going to be effective unless you actually talk about the people who have to do the work. This is kind of a graph that was put together to illustrate facility staff training in the ideal perspective. And what you want is your building commissioning experts to come in and do a lot of the effort at first. But in the end, you want a lot of that introductory effort to be an education of the facility staff to where they understand things that they previously didn't. What that enables you to do is to take on the higher order issues. So you're not dealing with air terminal units that they don't understand, or you're not dealing with occupant comfort complaints, but you're really dealing with things like, okay, how do we optimize the chiller and the condenser water system operation? And the way that you can actually get to that effort is to utilize training of the staff. I say up here, teach vigilance. Teach the staff that they need to be paying attention to the building operation system, building automation system, and tell them what they need to be looking for. And then you have to be available to them. You have to be accessible so that when they have questions, you can answer. You might have to answer the same question 4 times, but they'll eventually get it. They might get it the first time, but you just have to be accessible to the facility staff. And as long as you're doing that, you're going to be able to see that your effort can go down, and then their effort through education, through vigilance, conscientiousness can go up, and they can manage the facility better year after year, month after month. Okay, this is kind of my bucket of other considerations, things that I didn't really want to talk about a lot, but it's worth mentioning. Building automation analytics software. How many of you have like an overlay that does some sort of analytics? Anybody have any sort of automation system like that you can look at and it's going to spit out metrics for you? Okay, well, these exist. I would warn you, be wary of anyone who is selling this to you. It's easy for people to sell it, but it is hard to implement. And from what I've seen, the implementations of the analytics software have not been great. Just like before, if the trend data is not reliable, it's garbage in, garbage out. The same thing can be true for building analytics software. So if you buy into one of these systems, make sure you're getting exactly what you pay for. Make sure you're having someone like an ongoing commissioning agent review what you're purchasing from these vendors, because most of the time they do not understand the facility as well as the operating staff or as well as the ongoing commissioning personnel.
Hey, I have a quick question. Is that the same thing as BAS?
So what I'm talking about here is you have a building automation system that let's say that's JCI or Siemens or Trane, and it's what people call a front end. It's a computer that screen with all the graphics that show you how things are operating. What I'm referring to here, the automation analytics software, these are overlays that are provided by some vendors who look at the information coming into the building automation system and provide some sort of automatic analysis to tell you, oh, you need to be changing this or that. You have an air terminal unit that is not working, that kind of thing.
So is that the program that sends my mechanical contractors a message that something's failed?
Yes,
And when I look at the graphics, and I'm looking red X.
it is.
That's
And-
on a BAS too, though.
Oh, Johnson will do that as well.
And, what's that?
That,
Johnson will do that.
I think,
Yeah, so
I think,
building
Joe, he's
automation
saying that's a
systems will do
BAS.
that. The other, so the overlay will also do that, and it won't. So building automation systems are a little bit simpler. That they may have some rudimentary alarms that will tell you when you have something wrong, but really the analytics software will tell you you need to optimize your chilled water system. In this way, you should be changing this or that, or they'll take a group of metrics and use the aggregate of those metrics to tell you that you need to be changing something, or that maybe something is wrong. Wherein, a single sensor won't tell you that. That's kind of my best explanation of that software. And I've seen it poorly implemented. It can end with nuisance alarms and bad information and just bad intelligence. So I don't want to say don't do it, but if you do it, make sure you know what you're doing. Make sure that you trust the people that you're paying to implement it. Probably you want to have an ongoing relationship with those people, not just a one-time purchase. Demand control ventilation. Okay, that's just essentially demand control ventilation is really looking at CO2 levels and figuring out, should I augment my ventilation? Can I reduce it? Because especially in warmer, more humid climates, The more outside air you pull in, then the more you're going to be paying to condition that outside air. Building pressurization. So building pressurization is pretty important. You don't know it until you have a negatively pressurized building, and a year or two later, you've got moisture, mildew problems, and that is a very costly problem to mitigate. So just making sure that you have a positively pressurized building, more outside air than you have exhaust air, is a pretty important thing to do just in the introductory stage of your ongoing commissioning efforts. Energy savings versus occupant comfort. You can run into a case where your facility staff is so exuberant to save money that they end up compromising occupant comfort by basically limiting the conditioning efforts of the HVAC system. So it's something to consider if you're really wanting to save money. You know, you cannot let people adjust the thermostat below 75. I've seen that in a building.
Instead of changing lights, you just turn them all off.
Yeah, everybody's angry and you're saving a lot of money. Testing of life safety equipment. Okay, life safety, let's take something like stairwell pressurization fans. You don't save any money on those because they never work. But when you need them to work, you want them to work because we're talking about, you know, a fire alarm scenario. You got smoke in your stairwells because your stairwell pressurization fans haven't been tested for 15 years. This is an important thing to consider. Life safety type items that are not really about, you know, saving energy, but it's about saving people's lives when it really matters. So stairwell pressurization is a great example of something that you should be looking at annually to make sure that it works. Consideration of newly affordable technologies. So my best example for this is, you know, 25 years old or 30 years old. But at some point, VFDs became so cheap that it made sense to put them on any motor over a certain size. There are a lot of existing facilities that have, you know, fans and pumps, all kinds of motors that are not utilizing VFDs. And that's kind of the low-hanging fruit. So when you get into an aged facility with an old HVAC system, you should be looking at motors and asking the question, you know, what can I do here? Can I put VFDs on these? A lot of times you don't want to put a VFD on the existing motor, but you want to tell the owner, hey, when this motor dies, let's get a VFD compatible motor. So just put that in their head for when you have to replace it. Oh, also, okay, building enclosure. The one thing I'll say about building enclosure is a lot of times people think that they have a building enclosure issue when they have moisture and mildew problems in their facility. They think this must be building enclosure. But from what I've seen, the first thing you need to look at when people start saying, I can't figure out why my space seems like it's not conditioned, why I have moisture and mildew issues, the first thing you need to look at really is not the building enclosure, but you need to look at the pressurization of the building. Because as long as you have a positively pressurized building, it might be leaky, but you want the conditioned air blowing out and not the unconditioned air sucking in. But building enclosure is a consideration, and that is a service that a lot of commissioning agents offer. Going backwards here. Building analytics software issues. You might encounter firewalls with your own IT people, which make it difficult for you to actually implement the things that you want to do. Poor training, so they charge you $100,000 for a system and they don't tell you how to use it. You'll look at the graphics and you'll find that the guy that's putting it together doesn't actually know your building. He'll have pumps, you know, wrongly oriented with the chiller. Maybe they're pulling out of the chiller instead of pushing in, or vice versa. It doesn't really The point I'm trying to make is when you look at their graphics, a lot of times they haven't paid as much attention to what they're trying to show you on the graphics, which can be misleading. And then that can lead you to the wrong conclusions. So that's the graphics don't represent the equipment of the facility. Nuisance alarms. Does anybody here sit at a front end of building automation system on a weekly basis? This is one of the biggest things people complain about.
We don't pay attention.
Oh, yes. As a matter of fact, one of the funniest things that I think I've seen is when sitting with a controls technician. They were getting so many nuisance alarms that it was not even a conscious effort anymore for the mouse to dart over to the corner of the screen and silence the alarm and keep on doing what they were doing. I mean, this is something you will see if you spend enough time with controls technicians. Those nuisance alarms, they just don't pay attention to them anymore. And sometimes alarms are important, but if you have 100 nuisance alarms and one important alarm, what's the point? Okay, so these things pretty much have a high first cost, and once you've sunk your money into it, you're kind of married to that product. So, just be careful if you're going to implement any kind of building analytics software. Okay, we talked a lot about a whole bunch of the stuff about like really kind of technical things or practices that you want to use, but you really have to talk about the people doing the work. What are the roles? If you don't have the right people, this isn't going to work, or it's not going to work for long. So the roles that I've laid out here is obviously the ongoing commissioning provider, someone to come in and tell them what to do. And then you've got two different levels of the building owner. You have sort of the executive person who holds the purse strings and can make the decision to actually purchase your services. And a lot of times, that's not the same person as the facility staff who you're looking to educate and work with on a day-to-day basis. You need both of those people to be invested in this effort. You can't do this on your own. No matter how much they're going to pay you, you need conscientious, intelligent facility staff who care about the building, and then you need an owner who's savvy enough to realize that they're going to save money by spending this little money on the ongoing commissioning effort. There are also some contractor roles that you may choose to involve, particularly in the introductory effort. Test and balance, mechanical, particularly controls contractors. Those will definitely be involved in the first year. And then electrical, of course. This is just a little bit about what you're looking for in the ongoing commissioning provider. You want some bench depth. You don't want some sort of one-man operation who may not be here next year, and then you lose a lot of information because this person is gone or they chose to not pursue the ongoing commissioning effort anymore. So you want some bench depth, a team. If you're going to be doing Energy Star, you either need a PE or a licensed architect to actually sign off on that every year. So it's like an engineering stamp. You just got to say yes. We have reviewed the building operations and we've certified that this is correct. Not really talking about Energy Star very much today. You want a team player and someone who's easily accessible. When I say team player, what I really mean is someone who wants to work with people. You can have some excellent engineers, but if they don't like working with people, working with facility staff, it's not going to be a good experience. And it may be that they can save a lot of money, but it's an unpleasant experience that could end in the owner of the facility deciding to either go with someone else or just not continue the effort. You really want someone who's spent a lot of time doing commissioning. So if you're working with somebody who's been doing design for 20 years, they may not really understand what it looks like in an existing facility. They may not understand what you're going to run into in a 20-year-old building. So make sure that you're utilizing someone who spent a lot of time in existing facilities, has worked with facility staff, and is actually aware of the sort of things that you're going to run into in an existing building. Oh, And it's also great if you have someone who has designers in-house, because in an aging building, it is very probable that you're gonna wanna make some changes, and it's good to have that relationship with a commissioning provider who also has design engineers. So just some thoughts on if you're looking at, you know, who you wanna utilize for ongoing commissioning services. Okay, these are just some roles for the owner, and just some keywords. You want your executive decision maker to be informed. You want them to be decisive, meaning they're not hemming and hawing about taking on the effort. Someone who can actually say, yes, okay, let's do this. You want them to be capable of making the financial decision, holding the purse strings. You also want them to have some degree of authority over the IT and security people, so that any information that you want to utilize through trends and things like that, you can actually get that action undertaken. And then facility staff, this might be the most important role, even maybe more important than the ongoing commissioning provider. Conscientious, someone who's curious, asks questions, will pick up the phone and call you when they don't understand what's going on in their facility. They're trainable, communicative, and they're someone who wants to take on more responsibility. You don't want the person who just sits at the computer, and as long as there's no alarm, they don't care what's going on. You want someone who wants to make progress just as much as you do. If you don't have that in your facility staff, then your efforts are not going to be as fruitful as you want. And with that, it is 9 o'clock, and we can open up the floor for questions. Thank you very much for your time today.
Thank you all.